Okay guys, today we are starting our exponents unit, always one of my favorite units, and we're just going to start by labeling and defining the different parts of the following expression, and we're going to use the words power, base, and exponent. My guess is that the easiest one for you to notify is that exponent there of 3, and if we're going to define that, I like to define that as the number of times the base is multiplied by itself. Right, and we can see it's 4 to the third, and we see 4 times itself 3 times. Okay, then obviously 4 would be our base. That's the number directly below our exponent, and I like to think of that as our number or variable that is repeated in multiplication. So the number or variable getting multiplied by itself. The one students have most difficulty with is power, and power is really just the entire expression. So that was a nice sort of example we're familiar with maybe from 6th grade. I'd like to make another example, and I'm going to do that below here, so I suggest you take a little note here. Let's take the example of 2x to the third, okay? So I can see our exponent of 3. Now the question might be, well, what's the base? Is it x? Is it 2? Well, 2 is actually a coefficient. Okay, and we'll adjust our definition of coefficient for our exponent unit a little bit. In our algebra unit, we said a coefficient was the number being multiplied to the variable, which works here, but to extend our definition, it's really going to be a number or a variable that is multiplied to the base. Okay, so in that example, 2x to the third, 2 is the coefficient, x is the base, 3 is the exponent. Now, 2x could be the base if we altered one thing. If instead we put the 2x into parentheses. Now, the full 2x would be the base, and again, still the 3, the exponent. Let's just take a second to look at the difference within these expressions and see how the parentheses change the expression. And let's look at what it is when we expand the expression. So I'm going to use that word expand. We're going to use that word a lot in this unit, and expand means to show all multiplication. That'll be a good vocabulary word. So if we take 2x to the third, no parentheses, and I'm going to expand that. I know there's multiplication between the 2 and the x because 2 is a coefficient. And then the x to the third, there's multiplication. X times x times x. That's the power expanded. However, in 2x to the third, where 2x is the base, right? That's going to be that base, 2x multiplied by itself 3 times. So we can show it expanded as 2x times 2x times 2x. Okay, so to help us with naming our base, and because I miss having fun with you guys in the classroom, I thought we'd play a little pretend game right now, so get ready, get intense. There is a prize for it. We're going to play everybody's favorite game, Name That Base. So we're going to put 30 seconds on the clock. You have to go through name base. If you name the base of each expression, if you get all of them right, there's a prize at the end. Okay, ready? And away we Go. X squared, yes, the base is x. 5x to the third, yes, the base is also x. That 5 is the coefficient. Negative x to the fourth, no, the base is x. That negative 1, that's a coefficient. The negative is negative 1 times x to the fourth. But what if it has parentheses? Negative y to the squared, yes, the base is negative y. 3 squared, yes, the base is 3. Negative 3 squared, no, the base is 3. It's negative 1 times 3 squared. The base is 3. Come on, guys. Xy to the third. Yes, you guys got that one. Y is the base. That's that x times y to the third. The x is a coefficient. Xy to the third with parentheses. Yes, xy is the base. And then 1/2 to the third power. Look at those parentheses. Yes, the base is 1/2. Let's see. Did they do it? Did they win it? Yes, you just won. Name that base. And what's your prize? A llama keychain. So something we want to think about with our exponents is that, it's really a shortening of another operation. So sort of a shortcut for mathematicians, which we've already been seeing where repeated addition led to multiplication. So why would we add 5 plus 5 plus 5 3 times if we can just quickly do, 3 times 5, 15. Mathematicians came up the same thing with exponents. Exponents is just a shortcut of repeated multiplication. So instead of doing 5 times 5 times 5, we're going to do 5 to the third. In our exponents unit, we will have use of a calculator, but it may be helpful to know our powers of 2 to the first through 2 to the 7th or 8th is a pretty good one to know, as well as our powers of 3. Just convenient and easy for quick recall. We're working on page 3 in our exponents booklet. Again, remember you want to print your exponent booklet pages from the PDF, not the Word doc, because there were some formatting issues with the Word doc. Okay, so we're going to represent each expression as addition or multiplication and simplify it if you can. So we're just going to look for the repeated reasoning. 2 plus 2 plus 2, we can show that as multiplication as 3 times 2, which is 6. 3 plus 3 plus 3 plus 3 plus 3. 3 being added 4 times, we can show that as 4 times 3, which is 12. Likewise, we can also do this with our variables. A added to itself 3 times, 3a. B added to itself 5 times, 5b. And let's just go over here and correct. We were actually multiplying 5 times 3, which would have given us 15. Good catch there. Okay. As we move on, now we see repeated multiplication. 2 times 2 times 2, we can write that as 2 to the third, which 2 times 2 is 4, times 2 is 8. Make sure you have that note of 2 to the third there before we simplify. 3 times 3 times 3 times 3. 3 to the fourth power. 3 times 3 is 9, times 3 is 27, times 3 is 81. This also works with our variables. I think even easier with variables. A times itself 3 times. A to the third. I see our base is A times itself 3 times, exponent of 3. B times itself 4 times, B to the fourth. Okay. On our next step, it gets a little more complicated because we do have addition mixed in there, which separates out our multiplication. So we really have 5 to the third plus 5 squared. 5 to the third is 125. 5 squared is 25. So that would be 150. Okay. And again, with our variables, I see multiplication of variables separated by addition. That would be a to the third plus a squared. Now notice, these are not like terms. They have different exponents. We can't combine them. This is fully simplified. Okay. Now, as I look here, I've got g times itself 3 times, d times itself 4 times being multiplied together. So we can do that. G to the third times d to the fourth, and we write them right next to each other. They're variables. We're showing that multiplication by them being next to each other. Okay. G times itself 3 times plus d added to itself 4 times, well, that's going to be g to the third plus 4d. So we're just combining our repetitions. We're seeing repeated multiplication and repeated addition in one expression. Okay. On the bottom here, we have g added to itself 3 times plus d added to itself 4 times, which will give us 3g plus 4d. And those are not like terms, so that is fully simplified. Okay. Now, 4 to the third minus 4 squared, let's think about what that is. 4 to the third, well, that's 4 times 4 times 4. So 16 times 4, which is 64, minus 4 squared, which is 16, is, let's see, 64 minus 16 is 48. And we break that down and we simplify it. Very often I see students incorrectly thinking 4 to the third minus 4 squared would be 4. Clearly, that doesn't work. That's not correct. Okay, those aren't like terms. We got to simplify them first. Okay. On number 2, we're going to write each as a product of the same factor. In other words, expand. And remember, we said in our do now, we said expand means show all the multiplication. We're also going to discuss what's the base. So hopefully our game of name that base helped. So on A, we have negative a squared, no parentheses. A is the base. I want to think of that negative as a negative coefficient of 1. Negative 1 times a squared. So if we're going to expand that out, we're going to show it as negative 1 times a times a. Now, other mathematicians, other people, they might say, well, can I just show it as negative a times a? Okay, I think it's stronger showing it as negative 1 times a times a. Okay. On B, the parentheses, that shows me that the base is negative a, so expanding it, we're going to show it as negative a times negative a. So I'm really highlighting and showing what the base is. Okay. 3ab squared, there's no parentheses, so that 3a is really a coefficient. So I want to expand out that coefficient, 3 times a times our b squared, which is b times b. Okay. However, on D, now we have parentheses around it, showing us that 3ab is the full base multiplied by itself twice. We're going to show that as 3ab times 3ab. Okay. E, we have a over b to the second power. Our base, because it's in parentheses, is a over b. So we would show this as a over b times a over b. With F, we have almost the same thing, but we have a negative on the outside, a coefficient of negative 1. So we'll show it as negative 1 times a over b times a over b. Okay. On 3, we're going to expand the expression and simplify. Okay. So as I expand it, that's going to be negative 1, because it's not the base, it's a coefficient, times 4 times 4 times 4. I know 4 times 4 is 16, times 4 is 64. So negative 1 times 64, which gives us negative 64. On B, 3/5 to the second power, 3/5 is the base. So that's 3/5 times 3/5. Remember, fractions multiply straight across. 9 over 25. Okay. C, 2 over negative 3 to the third power. We expand that. That's going to be 2 over negative 3 times 2 over negative 3 times 2 over negative 3. Our numerator is going to be 8. Our denominator, negative 3 times negative 3 is positive 9. Times negative 3 is negative 27. So we have 8 over negative 27, or you guys know I always like my negatives up in the numerator. Okay. And then D, when we expand that, we have that coefficient of -1. -1 times 9 over 11 times 9 over 11. So -1 times 81 over 121, which will just be -81 over 121. Okay, excellent. Now, number 4, we're changing our work a little bit. We're going to make the exponents work for us. Evaluate each expression for the given value. So really what we're doing is we're substituting in. And remember, substitute in, we use parentheses. So we're evaluating -2x squared for x equals -3. When we substitute in, that's -2 in parentheses, -3 squared. And let's expand that out to see what's happening. That's -2 times negative. So on number 4a, we've substituted in -3 for x, and we've expanded it. -2 times -3 times -3. -2 times -3 is +6. +6 times -3, -18. Okay. On B, -2x squared, notice the base is -2x, and we're going to substitute in for x equals -3. So we've got our parentheses -2. Now I substitute in using my parentheses, so it's showing that multiplication. PEMDAS order of operations, we've got -2 times -3, which is +6. So I've still got those parentheses I'm going to leave in there. +6 squared tells me 6 times 6, which is 36. One thing I really want to emphasize before you go off into your classwork is, are these the same? -3 squared without parentheses and -3 squared with parentheses. Is there a difference? And there is. Those parentheses make a huge difference. Without the parentheses, this is -1 times 3 squared, which will be -1 times 3 times 3. Which will be -3 times 3, or let's say -1 times 9, which is -9. And with the parentheses, the base is -3, so this is -3 times -3, which gives us a +9. This is a fact we'll keep coming back to throughout the week, okay? So you guys are going to go on, you're going to complete page 4 in your booklet for classwork. It'll be submitted through our Google Classroom assignment. Our math joke for Matthew folks today is more of a one-liner. Here it is. Jake told Jen a story about decimals, but she didn't get the point. All right, guys, have a great day.